Okay, so I caught myself here. So we have our original given triangle. All these pink pieces are given. These blue pieces are what we need to solve for, specifically here and here. Okay, we're going to have to use the law of sines, right? The law of sines is, and you know what the law of sines, I hope, but the law of sines, what we're looking for the law of sines is any side with an angle given where they're opposite, right? So that's going to sort of help us solve this whole thing out. And what we have here is a 20. And we have a 30 degrees, so we know these two are going to be something we use. And then we're using 28, and we're using D here, because we know those things you need something to use. So we set it up as sine of D over 28 equals sine of 30 over 20. And we work it all out. We may get a value here, multiply by 28, and then we're going to end up with sine of D equals 0.7. Then we take the sine inverse of both sides, and we end up with sine inverse of sine is just D. Sine inverse of 0.7 is 44.43. So 44.43 degrees, right? And we put it in here, but we realize two reasons. Even if we don't have the diagram here, we put this here, this would mean that this is 135 degrees and that this is 135 degrees, and that just can't be the case. So this value right here really needs to be 180 minus 44.43, or 135 point, what does it come out to be? 135.57. Okay, so what happens here is this, and this is why you have to be careful with the law of sine. The ratio, when I'm talking about sine of a degree, this is always going to be, when I do sine inverse, this is always going to be from 0 to 180. Okay, I'm sorry, I take it back, from negative 90 to 90 degrees. So it's always going to be that when we're talking about inverse of sine. And the reason is this. I'm reluctant to get this deep in, but I'm going to just because I think it'll help in the future. So when we're talking sine inverse, this is my sine curve, right? And this is my sine curve. So this is really my sine curve I'm talking about. But notice, if we're talking inverse, we're talking what y value produces what x value. And if we go beyond this piece right here, or if we go beyond this piece right here, it then stops being a one-to-one function. This curve comes back on itself. Therefore, our domain is restricted to 90, negative 90 to 190. But that doesn't mean that we discount everything else, because the truth of the matter is, what we say here is, what angle, when we take sine of it, gives me 0.7? And the answer was 44.43, which is true. But because sine is the y value, and because it's positive in the first and the second quadrant, we're talking xy, then we take 180 and we subtract this, and that'll give us 135.57. And if we put that in our calculator, we would get, for sine, we would get 0.700 something. So this is the answer we want. So both of these will give us 0.7. Remember, this is what sine inverse of 0.7 is saying. But this is the one we want. So we need to be careful that with inverse trig. That being said, when we go here, this is our 44.43. And therefore, because these are equal, this is our 44.43. And lastly, now we can figure this whole thing out. When we subtract 180 minus those two values, this value, BCD, equals 91.14 degrees. That's the first one, okay? Secondly, when we're looking at this full triangle right here, actually we can do it two ways. We can have a 30, a 135, and a little sliver there. That's what I'm going to do. 180 minus 135.57 minus 30, and this little sliver up here is 14.43 degrees. And that's 14.43 degrees. And that is that. Okay? All right, that's the first one. That's a lot. It's especially important to know this bottom part. We'll talk about later. Well, you might talk about later, but that this is going to be something that shows up again and again where you need to be careful with signs. Okay, so number 28 is going to be a similar type of problem. We're looking for this value of x, which means, let's see, we're going to have to find that value of 25 works, and we have this value of 12. So really, because we have that 12, because we have a 12 here, we can get this from there, but let's see if we can go a couple different ways. So right now, I'm going to be looking at a and 12. I'm going to be looking at x and 25. All right. So eventually, we are going to have x. Remember, we always put our unknown on top over sine of 25. That's going to be part of our problem for sure. And we want to know this 12 is going to be on top, so we want to match up the sides. And we want to know a. So once we find a, then we can complete this problem and get to find out what x is. So to find a, we're going to have to do one of two things. We're going to have to deal with these angles right here, or this angle right here. If we get this angle right here, then we can add it to 25, and we can have 3 angles for 180. If we get this angle right here, then by supplemental angles, we can find this one right here, and then we can use these 3 angles for 180. So, yeah, I'm just going to go right here. This is going to have to be 25 now that I say that out loud. So I'm going to do this side work here, and I'm going to solve for, oh no, I take it back. We're not looking for that angle. Yeah, this has got to be 25. Ready? So I'm going to do this piece right here. And I'm going to have sine of unknown. That's the sign of the little blue sliver. I'm going to call it, well, it's not labeled on our calculator, on our table. I'll call it C. Divided by 12 is equal to sine of 25 divided by 12. So this is going to be 25 degrees, for sure. That blue angle is 25 degrees. Okay? Which means our entire angle here is 50, which means we have 50, and we have 25, and we have this bottom angle A. So bottom angle A comes out to 105. Angle A, or equals 105 degrees. Again, we're looking at the outer triangle here. This angle right here is 25. We just solved that law of sines. This angle is also 25. They gave it to us. Therefore, this whole thing's 50. This angle here is 25. They gave that to us. So these two angles add to 75. And this last angle needs to add to 180. Therefore, that's 105. All of that, so we could do this. Sine of 105. And now from here, just as we always have, or not always have, this is twice now, we leave our unknown on top, and this becomes, in our calculator, 12 divided by sine of 105 times sine of 25. And x is going to equal 5.250. Get used to rounding to 3 decimal places. If we're talking angle, 2 is fine. But if we're talking side lengths, we're talking, yeah, I looked back in the book, and this was angle C. I missed that label to begin with. And my drawing is not to scale, so it's not a very good drawing. But if we have a triangle here with 12 and 12, the opposite angles are going to be the same. So if this is going to be 23, we can just go to opposite angles to get that. I use law of sines, but that's fine. And then once we do that, then we have our 3 outer angles, and we get to our A equals 105. Okay? All right, I hope that helps.